So let's say you get a quadratic expression below. What's the first thing that you should check based on what we did just now also? Number one is you should actually check if denominator is factorizable. Because if the answer is yes, we would have gone for partial fractions instead. Okay, so always check that first. In this particular question, no. If you check on your calculator, you will see you don't get nice numbers. So if it's a no, then you will want to proceed. I want to force out f prime x over fx. Okay, think of this like step 2. If I cannot do partial fractions, we force out f prime of fx. Okay, so what do I mean by that? Let me continue over here for this problem. Copy in the same denominator first. Leave the numerator untouched. I'm going to force out the f prime. So if this is fx, what is f prime? F prime will be 2x minus 2. You differentiate that denominator, we put it at the top. Let's balance the equation to get back to x plus 2. So the coefficient of x is 1. Force out the coefficient to become 1 again. So I put a half. So half times minus 2 gives you minus 1. I want to get plus 2. So you need another plus 3. Okay, my first step is to make sure I force this term to be f prime x. Okay, make that appear before you balance your equation. And once you have this, you split. Split the fraction at this plus, split into 2 fractions. Left-hand side, let me put the half outside. So we have 2x minus 2. For that term on the right, we put the coefficient of 3 outside also. Okay, so what's the point of trying to force out that f prime? It's for this particular step, you are going to get f prime over fx. So if it's f prime over fx, we know that we will get ln of that denominator. What about this term on the right? Your denominator here, we are going to complete the square because you aim for tangent inverse. So can I do the completing the square step on the left? You go and complete the square. You do a side working to work that out. It's a plus 7, but let me present as a root 7 squared. Okay, so let's change it in this problem. Left-hand side, we continue to copy. Right-hand side, when we reach this structure of x squared plus a squared, we will change to tangent inverse formula. So we get your 1 over a, tangent inverse of your fx over a plus c. But there's one more thing you should change. Now note that this term here is always positive. It's x squared plus a squared. So if it's x squared plus a squared, then it's always positive. You should change this ln to a round bracket. This ln will now be written as x squared minus 2x plus 8 round bracket. But we will explain, since this term is always more than 0, for all x values. On the right side, nothing else we can do except to simplify this. Okay, but what about this next one? I only made one change. In the initial question above, this is a +8, but I made one change to make it a -8 in this new problem. There will be a big difference because this term is factorizable. Must always check whether the denominator can be factorized. In this particular case, if I go and factorize it, we will get x minus 4x plus 2. Okay, this is a good example to illustrate to you, must always check factorizable, because if it can be factorized, like in this case, actually it becomes a lot easier. We're just going to get 1 over x minus 4. Okay, hence, we immediately get a ln equation.